It was January 7th in 1610 when Italian astronomer Galileo Galilei made an astonishing discovery using his homemade telescope. 4 moons orbiting the planet Jupiter. By the way, these days you can make your own version of his telescope using cardboard tubes, lenses, and some superglue. The main point of this DIY telescope is to place 2 lenses at the correct distance from each other. You'll need 2 lenses. One lens should be concave, the other one convex. So one lens is curved out and the other one is curved in. Galileo's initial telescope was able to magnify objects approximately 8 times. He continued to improve it until it reached about 20 times the magnifying power. But let's get back to the main story, shall we? When he first looked at those 4 moons of Jupiter, he believed he was simply looking at a bunch of stars. But he soon noticed that these space objects seemed to be moving in a regular pattern. It took him a couple of weeks to figure out that what he was looking at were not stars, but moons circling Jupiter. Galileo initially named those moons 1, 2, 3, and 4. But let's face it, those weren't the most creative names. As more moons in our galaxy were discovered later, the numerical system for naming them became confusing and impractical, so it lasted for just a few centuries. So, these days, those 4 satellites, Jupiter's largest, are named Io, Europa, Ganymede, and Callisto. They're collectively known as the Galilean moons to honor the man who first noticed them. Galileo's discovery was crucial for our later understanding of astronomy. It was initially believed that other objects revolved around the Earth since it was seen as the center of the universe. We now know that there are hundreds of moons in our solar system. However, large moons, like those discovered by Galileo Galilei, are not so commonly stumbled upon. A moon is considered large when it's the size of our planet or bigger. Ganymede, for instance, is bigger than Mercury. We basically call Ganymede a moon just because it orbits Jupiter. Otherwise, it has all the other characteristics of a planet. It's no surprise that Jupiter has the biggest moons in the area. It beats all the other planets in our solar system in both size and mass. So no wonder it pulled in a lot of other objects towards it. Jupiter is believed to have in total almost 80 moons, with only 53 of them being given official names until today. The first of those Jupiterian moons to be discovered by Galileo was Io. What sets it apart is the fact that it has a lot of volcanoes. Io is the only space object to have active volcanoes in our solar system, apart from Earth. It's also nicknamed the Moon of Fire and Ice because of its sulfur dioxide snowfields. Io's outer layer is splotchy, featuring multiple colors like orange, black, yellow, white, and red. That's probably the reason why NASA described it as a giant pizza covered with melted cheese and splotches of tomato and ripe olives. Because of that sulfur though, Io doesn't smell that appetizing, something similar to a rotten egg. There are more than 100 mountains on the surface of this moon. They are a lot larger than those we see on Earth, some being bigger than Mount Everest. On average, these mountains are 4 miles tall and 98 miles long. Because of those active volcanoes and the intense radiation on Io, there's little chance that life as we know it could exist here. But hey, who's to say it can't have life the way we don't know it? Next on the list of Galilean moons is Europa, the smallest of the 4. It's comparable in size to the moon. Europa has an entirely icy surface, with just a bunch of craters scattered here and there. Because of that outer layer, Europa is very reflective, making it one of the brightest moons out there. As for its age, scientists believe its surface to be somewhere between 20 to 180 million years old. Europa is about 4.5 billion years old. What lies beneath that icy surface is impressive. It may even hold the secret to life outside Earth. Ice forms here in 2 ways. The first is through congelation. A rather self-explanatory process. Ice just grows as the surrounding environment gets colder and colder. The other method, though, is a lot more fascinating. A layer of supercooled water found under the ice shell reacts when agitated. It then generates these crystals that make it look like it's snowing in reverse, floating upwards to the ice sheet they sit under. You can recreate this environment yourself at home. Take a bottle of purified water and place it into the freezer. If you don't have purified water anywhere near, just boil some water a couple of times to get rid of as many impurities as possible. Since there won't be any particles inside, once in the freezer, it won't turn solid. But if you take the bottle out of the freezer and give it a shake, the impact will make the water rapidly crystallize, transforming it into a slush-like consistency. There may be water on Europa, but there's little evidence so far that life exists on this moon. However, it's one of the highest candidates in the solar system for potential habitability. Some sort of life forms could adapt to live there in its under-ice ocean. That environment is most likely similar to what we can find in our planet's hydrothermal vents hidden deep within our oceans. The amount of oxygen in Europa's atmosphere is very little, but in 2013, NASA gave away some cool evidence. This yet again supports the theory that there's potential for life on this moon. It seems that Europa might be venting water into space. If this is confirmed by future observations, it could also mean that Europa is geologically active. It could also come in handy if we'd manage to study water sources one day. The largest of those Galilean moons is Ganymede. It's also the biggest moon in our solar system altogether. It's a low-density space object similar to Mercury in size, but having only half of its mass. However, Ganymede is the only moon out there to feature its own magnetic field. It's quite small though, and we can barely notice it from Earth since it's overshadowed by Jupiter's much more powerful magnetic field. Another cool aspect of Ganymede is that its atmosphere contains oxygen. Don't get too excited, it's not nearly enough to support any life forms living there. Back in December 2021, a 50-second audio clip was released, which was previously recorded by NASA's probe on its Ganymede flyby. For the inexperienced, the sounds were more similar to those of an old dial-up internet connection, but because of its quirky tunes, Ganymede was soon nicknamed Jupiter's singing moon. Finishing up the list of Galilean moons is Callisto, or the most heavily cratered object in our solar system. What's interesting about this moon is that its landscape has barely changed since it formed, and scientists are still debating why this is happening. Most other space objects go through loads of changes throughout their lifetimes because of events such as collisions with other objects, changes in orientation or speed, or chemical reactions happening on their surface. Callisto is also about the size of the planet Mercury, but it has a lower density. Jupiter's magnetic field has a lesser impact here, since Callisto is the furthest from the giant planet. Its surface is estimated to be a staggering 4 billion years old. As opposed to Io, Callisto is not geologically active, but scientists believe there might be an ocean hiding underneath the moon's surface, which may potentially harbor life. The fact that it's less impacted by Jupiter's magnetic field means that it features low levels of radiation. Given this suitable environment, we may one day end up setting a human base for future explorations here.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.